The next thing that I want to talk about is wind damage. Now, there are two primary causes of wind damage. One is a downburst, or what we call straight line winds. The other is a tornado, and tornadoes have a converging damage path. With downburst, the damage that is done from a downburst can have either damage can be in a unidirectional pattern, which means all of the debris is laying in one direction, let's say from west to east. Or it can have a divergent damage pattern, kind of like a fanning out effect of the damage. Now, with downbursts, the damage that it causes does not show any signs of rotation or exhibit any large-scale rotational pattern. If it did, it would be a tornado. Also with downbursts, you can have small-scale twisting that can occur when the wind goes around different parts of buildings or trees or how it hits certain objects. You can create these little eddies and create this little twisting that can occur. That does not mean it's a tornado. Lastly, damage from a downburst can be as substantial as a low-end tornado. There have been downbursts that have produced winds in excess of 100 miles an hour, and it was not associated with a tornado at all. A downburst is an area of strong, often damaging winds produced by a thunderstorm's downdraft. When the downdraft hits the ground, much like a stream of water coming out of a faucet and hitting the sink, it spreads out rapidly in all directions and becomes known as a downburst. Downburst wind speeds have been known to exceed 100 miles an hour. Also, from a distance, downbursts can sometimes look similar to tornadoes. On radar, to warn for this type of storm, meteorologists typically look for converging airstreams in the midsection of the storm and a large precipitation core being held aloft by a strong updraft. If it is felt that a storm will produce damaging winds, then a severe thunderstorm warning is issued. There are two types of downbursts. There is the microburst and the macroburst. The microburst is a small concentrated downburst that affects an area less than 2.5 miles across. If the area of damage exceeds 2.5 miles across, it is then defined as a macroburst. In these series of pictures, you can actually see a microburst forming and then making impact with the ground, with these pictures taken by Mr. Bill Bunting back in 1991. Next, I want to show you a video taken by a meteorologist from the National Severe Storms Laboratory of a microburst in action. Once the microburst hit, winds were estimated about 70 miles an hour. So now I want to talk about tornadoes and how their damage path is going to be vastly different from that of a downburst or microburst. Tornadoes have a converging damage path, and this is a great picture to illustrate that converging damage path. You can see how the trees are almost lying in a crisscross pattern here. The trees over on this side are lying more in a southwest to northeast orientation. The trees over here are lying more in a south-southeast to north-northwest orientation. So the tornado probably went someplace right through the middle of the picture here. In my attempt to show you a great example of the difference between tornadic damage and microburst damage, I came across this image from Lyndon State College, which was a great example showing you the difference in pictures. On the left-hand side, you can see two different Examples of tornadic damage, you can see again the crisscross pattern to the trees clearly in this picture. In the bottom picture, you could definitely see the swirling or cyclonic pattern within the damage itself. Again, with microburst damage, the damage is going to be in a diverging or divergent pattern, basically a fanning out in all directions of the trees or debris or whatever's being damaged. So you could definitely see a distinct difference between the tornadic damage and the downburst or microburst damage. Okay, so let's move on to our last topic, and that is tornadoes. What I wanted to show you is a graph depicting the number of tornadoes that the National Weather Service office in Paducah, our area, has had since 1996. And you can notice that we've had quite a number of tornadoes, with a record-breaking year in 2011 and a year with not so many tornadoes in 2001. On average, our area receives about 25 or 26 tornadoes per year. So how do we as the National Weather Service rate tornadoes? We utilize something called the Enhanced Fujita Scale, and tornadoes are classified according to the intensity of damage that they cause to objects. We cannot rate a tornado simply by looking at radar or simply by looking at pictures of the tornado itself. We have to judge the wind speeds based on the damage that the tornado has done. And once we come up with wind speeds, we can append an EF scale to the tornado. So we go along the entire path from start to finish, and we figure out what the wind speeds would have to have been to produce the damage that was done. And whatever the highest wind speed that we can find along the entire path, let's say it was 120 miles an hour, was the worst damage and what we think were the highest wind speeds in that particular tornado. In that case, that would be an EF2 tornado. Now, the EF scale ranges from EF0 to EF5, EF5 being the most violent tornado, EF0 being the most weakest tornado. And in our area, this is a breakdown showing you how many EF0s, EF1s, and so on that we've had in our area. As you can see clearly, most of the tornadoes that occur in our area are EF0 and EF1 in strength, meaning that most of our tornadoes are weak. But we've had our share of strong to even violent tornadoes in our area. Luckily, since 1996, we have not had any EF5s. We also perform statistics on the time of day that the tornado occurs. As you can see from this graph, most tornadoes occur during the afternoon and early evening hours. But there is no time of day that is immune to tornadoes. What scares us most are tornadoes that occur during the overnight hours. And as you'll see here in a little bit, that is also when most of our deaths occur. Here is a breakdown of tornadoes by month. As you can clearly see, April and May are our main tornado months, and there are a few months that tornadoes are more rare in, such as July, August, and December. But essentially, tornadoes have occurred in every month of the year. And we definitely also see a spike here in the fall months and also the late winter to early spring months. I wanted to show you a breakdown of the number of deaths that we've had in our county warning area since 1996. We've had a total of 52 deaths, and they have occurred in several months of the year, but the highest number of deaths occurred in the months of November and February. Most have occurred in mobile homes, and the ones highlighted in the orangish-yellow color occurred at night. So quite a number of people have died during nighttime tornadoes. The best place to be during a tornado is a basement or storm cellar. One thing to be very wary about is that sometimes debris can collect and fall into the basement, causing injury. So it's very important that you try to take refuge underneath something sturdy, such as a workbench, and being fully aware of where heavy objects rest upon the floor above. If you do not have a basement, the next best place to be in a tornado is going to be on the lowest floor of your home and in a small interior room, such as a closet, bathroom, hallway, or under a stairwell. The key is putting as many walls between you and the outside. So you want to be on the bottom floor and in the middle of the house. Try to cover yourself with blankets, pillows, and even wear a helmet to protect yourself from flying debris. Getting down and crouching low to the ground as possible is very important. Stay away from glass and windows, as those will be the first to break during the winds of a tornado. With regards to mobile homes and vehicles, the best course of action is to find a nearby home or building. As a very last resort, you can take shelter in a ditch. The key is trying to allow enough time to get to shelter. Think ahead. During a tornado watch or a severe thunderstorm watch, have plans to know where you're going to go in the event of a warning. Another place that you do not want to take shelter is under a highway overpass. Winds can become channeled underneath an overpass or bridge, making the wind speeds increase. If you decide to take refuge under an overpass, realize that most overpasses do not have beams to hold onto or ledges to hold onto. And all tornadoes are going to have debris, so you put yourself at much greater risk for death or injury by taking shelter under the highway overpass. And lastly, you want to avoid buildings that have high ceilings, such as churches, school gymnasiums, shopping malls, etc. Even buildings that are large stores, such as Home Depots or Walmarts. There's a lot of building material, roofing material, that can fall into the building itself. In addition, some of these buildings have a certain type of construction in which, once the roof has been completely detached from the building, all of the outside walls tend to fall into or out of the building. In this particular case, you definitely want to try to find a bathroom or some kind of small interior room within these larger buildings. The last thing I want to make note of is that flying debris in tornadoes is what makes tornadoes so deadly. As you can see from all of the pictures here, even the smallest of objects can become deadly projectiles in tornadoes, and that is what you're trying to protect yourself from. So think about that when you're trying to decide where your shelter is going to be. We have reached the end of the presentation. I thank you for staying with me for all of the information that was presented here. As always, for more information, please visit our website or check out our other videos on our YouTube channel. Thanks for watching.